Good evening, all. Students, please inform your friends to join the session as soon as possible. Roshit sir, good evening. I hope my voice is audible.
Yes, Sushmita, good evening.
Yeah, you can start the session, sir.
Okay. Yeah. Okay, students, can you ask your friends to join fast? Put in your WhatsApp groups and ask them to join fast so that we can start the session. While I share my whiteboard, please ask your friends to join fast. Okay, so I'm sharing my screen now. Okay, good evening, everyone. How are you all doing? Yeah, good evening, Nagesh. Good evening, Mambiya. Good evening, Kajal. Good evening, Shahik. Good evening, Suyash. Good evening, Jinat. Good evening, Maskan. Okay, is the assignment done, everyone? Assignment done? Yes. Is it done? Good evening, Sandhya. Good evening, Anurag. Good evening, Gomatesh. Daily you will tell not done only, Anurag. One day also you did not told in the chat that you have done it. Okay. Try to implement. So what is the issue you are facing? So Sandhya, is assignment done? Muskan, Suyash, Kajal. Yes. Okay, let me know what is discussed in the last class. What is discussed in the last class? Yes. What is discussed in the last class? Stack using queue. Okay. Okay. So we went with the stack implementation, right? So we went with the stack implementation. Okay, using array. Using array we have discussed. Using linked list we have discussed, right? Using linked list also we have discussed. What is the problem with array? Array implementation, what is the problem? Fixed size, right? Fixed size is a problem, right? Fixed size is a problem that we can make it dynamic using linked list implementation, right? And then we have seen queue implementation as well. Queue implementations. Queue has how many ends? Queue has how many ends? Queue has how many ends? Two ends, right? Top end, like no. Queue has how many ends? Two ends, right? Rear end. From rear end, we will insert the elements. From front end, we will delete the elements, right? And then we have seen mm, here also array to array implementation as well as linked list implementation, right? And here also the problem with array is fixed size, right? And we have also seen vice versa. Like we have implemented stack, we implemented stack using queue. Using queue, we have implemented the stack as well. Okay. And then I asked you to do the reverse one, queue using stack as assignment to you. Okay. And then we went with the traversals, right? We went with the traversals. So many traversals are there, stack traversals basically. So these are stack traversals, right? So stack traversals, what are there? We have our infix, like basically traversal. We have our infix, we have our prefix, we have our postfix. And if suppose any expression is given, if any expression is given, okay, if any expression is given, we will be using this traversal. We will be using this traversal to find out that expression in to convert this particular expression using to convert this particular expression into either of these infix or prefix or postfix. So what is an expression? It contains operands plus operators, right? So operands in the sense it may contain a to z, 0 to 9, and 0 to 9. So small a to z also it can contain, right? And operators can be, you can have your braces, you can have your power operator, you can have your like minus, multiplication, plus, and division operator or percentile operator. These are all the operators can be contained in the expression. So basically, when the operators are happening in between, like this, if the expression is there like this, a plus b into b plus c. So this is nothing but a infix expression, right? This is nothing but a infix expression. Whereas prefix expression in the sense, you will have the star operator, and then you will have the plus operator ab, then you will have the plus operator that is for c. Okay, so this is nothing but the prefix expression, right? And then postfix in the sense, postfix in the sense, so basically after the thing you will have the ab plus and then bc, okay, then plus star. So this will be the postfix expression, okay. And if you see here in infix expression I have taken the braces, but in postfix or prefix expressions I'm ignoring these braces. I'm ignoring these braces. I'm just concentrating on the operators. I'm just concentrating on the operators. Are we clear until this point? Are we clear until this point? Yes. Yes, everyone. Okay. So then we will be discussing today the infix to prefix conversion. How we can do using or you can like infix to prefix conversion, or else you can also work on okay. So infix to, otherwise we will take it as postfix conversion. Okay. So how we can do this infix to postfix conversion, we'll see one. Okay. So using stack, how I can do that? Using stack traversal, how I can do this? Let's see. Okay. Suppose the expression is like this. Okay. Suppose I will take the expression P plus Q operator and C star D. Okay. And then suppose minus E. So this is the expression is there. Okay. This is called as infix or prefix or postfix. Infix or prefix or postfix. How you are telling it as infix? How you are telling it as infix? It is infix. How you are telling it? Because you have the operator in between, right? You have the operator in between the operands. In between the operands, you have the operator, so it is called as a infix. Okay. Now you need to convert this expression to postfix. Means postfix in the sense after the operands, the operator should come. Okay, after the operands, the operator should come. Okay. So what I will do, I will traverse over each and everything. Okay, each and every operand and each and every operator, and I will use a stack accordingly. Okay, so what I will do, suppose I'm writing some traversal expression. Okay, and you have the stack here. Okay, then I want the postfix expression answer. Okay, postfix answer. I need to convert this infix expression to postfix. Yesterday, I have told you one order, right? One precedence order. So if you consider this power operator as higher precedence, that is first rank. Okay. Then you have the like star division percentile. This comes under second rank. Okay. This comes under second rank. And you have the minus plus. This comes under third rank. Okay, this has a less priority. Okay, this has a less priority, whereas this power has a more priority. Okay, brackets have higher priority. Okay, brackets have more than higher priority. But the thing is, while conversion from infix to postfix, while conversion from infix to postfix or infix to prefix or prefix to postfix, using these conversions when you are doing, you don't take care of this priority. You will not consider this priority. Okay, while this conversion, while this traversals, you will not take care of this priority. You need not want this priority. You only need these priorities. Okay, you only need these priorities. Are we clear until this point? Yes, everyone. Okay, so now what is the expression is there? First one is like we have the brace, right? When you are finding the open brace, directly you can push it onto the stack. Okay, this is your stack. If you consider this as your stack, okay, directly you can push it onto the stack. Okay, and the answer directly you can push it onto the stack, and like answer will be empty now. Okay, answer will be empty, no answer. Okay, then you are next moving to I'm removing this, I'm removing this, I'm removing this, I'm removing this, I'm removing this. Okay, let me take another color. Okay, now the pointer is at here. Okay, so now this is operand. Okay, this is operand. So when it is operand, you will not push it onto the stack. You will not push it on the stack. So what will happen? The stack will still contain the opening brace, and just you will attach it to the answer, append it to the answer, that is P. Okay, that is P. Okay, and then the next one is this one, right? Plus. When it is a plus operator, you will directly push it onto the stack. Okay, you will directly push it onto the stack. So the stack will contain both. The stack will contain like opening brace and then plus operator. Okay, then it will the answer will contain still P itself. Okay, then when it is Q, again this is operand. Again this is operand. Again this is operand. When it is operand, you will not do anything. You will just attach to the answer PQ. Okay. Now next one is closing brace. Okay, next one is closing brace. When you find this closing brace, immediately what you will do, you will pop it up. Okay, you will pop it up from the stack until you find the opening brace for that. Okay, you will pop until opening brace is found. So what you will be doing? You will pop this. You will pop this. Means now the stack is again empty. Okay, now the stack is again empty, and what you will do? You will attach that operator. You will attach this plus to here. Okay, you will not attach the opening brace. You will just append the answer with the operator plus. Okay, and then you have the power operator. Okay, then you have the power operator, and if you see the power operator, the stack is now empty. You will directly push it up, and the answer will be PQ plus. Okay, and then you have again the opening brace. When you find the opening brace, directly what you will do, you will push it onto the stack. Okay, PQ plus, and then you have the C. What you will do, C, this is C. Okay, so what you will do, C, you will not push it onto the stack. You will just attach it to the answer, PQ plus C. And then you have the star operator. Okay, you have the star operator. So you can directly, so here it will be there. Okay. Okay. And then when you have the star operator, directly push it onto the stack. Push it onto the stack. And then you have the D. You have the D. So D, what you need to do? This is your power operator, star operator. So here you have the PQ plus C. You will append the PQ plus C D. Okay, PQ plus C D. And then you have the closing operator, closing brace. So closing brace, what you need to do when you encounter the closing brace, what you need to do? You need to pop it out until opening brace only. Until opening brace only, you will pop it up. So now what will happen? PQ plus CD star will be appended. Okay, then in the stack there will be only power operator. Okay, and then you have the closing brace is done, and then you have the minus. Then you have the minus. So if you can see now, minus has lesser priority, minus has lesser priority than your power operator, right? Minus has lesser priority than your power operator. When it has lesser, when you are encountering lesser priority than the top of the stack, then the top of the stack, then what you will do, you will just pop it up. You will just pop it up. So what will happen now? CD star your power operator. Okay, and then you will push it this minus to the stack. Then you will push this minus to the stack, and then you have the E. So E, what you need to do? E, what you need to do? Just you will push it onto the stack. Okay. Star, then dollar, then E. Okay, and then any other is left here? Any other is left? No, nothing is left. So what you will do? What is there on the top? Everything you will attach. So what is there on the top? Only minus is there. So that you will be attaching. PQ plus CD star dollar E minus. So like this you will do. Okay, so this is your infix expression, right? P plus Q power C star D minus E, right? So this will be the postfix expression. So postfix in the sense after the operators. After the operators, and then you have the CD star. Okay, and then you have the power operator. Okay, then E minus, E minus. Okay, so this will be the postfix expression for that. Are we clear? Yes. So what you need to check basically, what are the conditions here we have encountered when it is operand. When it is operand, A to Z or small a to Z or 0 to 9. So what you are doing, directly you are appending to the answer. Answer plus. Okay. When it is operator, when it is when it is operator. So what you are doing, you are checking it. You are checking this operator. You are pushing onto the stack. You're pushing onto the stack, but before pushing, you are checking whether the particular operator you have encountered is priority is lesser than the top of the stack. Then what you will do, you will just simply pop and append to the answer. If it is greater, if it is greater than the top, if it is greater than the top, then what you need to do, you need to just push. You need to just push onto the stack. Okay, and when you encounter opening brace, what you need to do, you need to just push it onto the stack. Okay, when you encounter closing brace, what you need to do, you need to pop until you encounter, pop all the operators. Okay, pop all the operators until you encounter opening brace. Okay, so these are the conditions you should be following. Are we clear? Are we clear? Yes. Can I get a quick heads up in the chat box? Okay. So let me go to the code. Okay, so see here, I have the code already written. So in fixed to forced to fix. So what you are doing here, you're taking a stack. Stack is of what type? Stack is of what type? Character type. Okay, stack is of character type, and then you're creating a stack, and then this is what this is called. It is generic, right? Means only characters only can enter into the stack. You have created the stack, and then you are creating some string builder. Okay, for appending your string. Okay, for appending your string, you can use string also. That's fine. But string builder, what it means like if you are doing, you will do multiple appends, right? Like this also you can do. Okay, result one is equal to dollar. Okay, like this also you can append the string. Like this also you can append the string, but the thing is updation will happen always. Updation will happen always. Okay, updation you're doing after once you encounter the operand, directly you're appending, always you're doing the appending. So in Java, basically what will happen means when you're appending always, it will create a new object when you're going with the string. It will again create a new object. Okay, it will result in creation of the new object always. When you're appending A, it will get a new object. When you're appending B, it will again create a new object. Like that, it will go on creating. Okay, so for that reason, we are going with, we are using the string builder. It will use the same object always. Okay, same object reference always. Okay, so for that reason, we are going with the string builder. So everything is same. String and string builder, everything is same. But the thing is, string builder, it will append. When you are appending, it will use the same object. Okay, but when you go with the string, it will keep on appending. Okay, so you are taking a string builder and then you are starting a loop for traversing along your expression. Okay, for traversing along your expression. Now you are taking the first character s dot caret of I. Okay, s dot caret of I, and then what you are doing, you are checking whether it is character A to Z or capital A to Z or 0 to 9. Then what you need to do, just you need to append to the answer, append to your result. If else, what you need to do, else if it is opening brace, if it is opening brace, directly what you will do, you can push it onto the stack. If it is closing brace, if the operator is if the operand is closing brace, then what you will be doing, you will pop it up, you will pop it up until you will pop it up until you find the opening brace, right? You will pop it up until you find the opening brace. So what you need to do, until it is empty, until the stack is empty, you will go, otherwise till you find opening brace, until the stack is empty, till the stack is okay. So then you will append it up, then you will append it up to the result, then you will append to the result. Are we clear? Yes. Then what you will do, you'll just pop it up. Means until you find the opening brace, you keep on popping and append it to the result. Okay, then you will pop. Again, you will append to the result, then you will pop. Like this, you will keep on doing. Okay, and then else, and then else. So other than this operation, if any operator plus star division, like that, any operator if you're having, then what you need to do, you need to check the priority, you need to check the priority while it is empty, or peak is equal to opening brace, and you will be checking the precedence, you will be checking the precedence, what is there on the top, what is your operator, what is your operator. So what is there on the top, suppose the top has higher precedence. Okay, the top has higher precedence, then what you are encountering, then what you will do, you will simply pop. If it is equal, if it is equal, or if the precedence is equal, suppose star star again you got it, then the precedence is equal, or what you are doing, or is right associate of C. So basically you are checking whether they are equal or not. Okay, then what you are doing, you are just appending to the result by popping it, and then you will push the operator onto the stack. You will append you whatever is a greater priority, you will pop it up from the stack, and then you will push the that particular operator. So this is how we will be doing the infix to postfix expression. Okay, then what you will do, if you, until it is empty, all the remaining conditions were done, now only one operator is, that is minus, what you need to do, just you will append it to the result. Okay, you will pop it up and you will append to the result, then you will return the result. Okay, so how you will check this, so this is how you will do the infix to postfix conversion code. Okay, like how you will check, how you will check this precedence, you can ask me how you can check this precedence. So what you need to do, you will be writing these things. Okay, you will be writing some function. If C is equal to, what you will do, you will take it as 3, means higher priority, or you can take it as 1 also, that's fine. Okay, else if it is star or division, you will return 2. If it is plus or minus, you will return 1, else return -1. Like this you can go ahead. Okay, like this you can go ahead. Okay, okay, this one I have written just to return this like power operator. Okay, I'm not mentioning here the thing, and I'm mentioning it. Okay, so right associativity I'm checking. Okay, so this is how you will be writing the code for the infix to postfix expression. Okay, I'll be sharing this code to you. You can put it in your editor and just execute it. Okay, you can put it in your editor and just execute it. Okay, exceeded. I'm sharing it in multiple chunks. Put it in a editor and execute it. Okay. So this one all I will share it at once. Okay. Okay, I've shared it in multiple chunks. Please put it in an editor and execute it. Okay, and let me know if you're having still any doubts. Okay, let me know if there are any doubts. Please put it in an editor and let me know if you have any doubts. Okay. Is it done, guys? Like executing this code is done? Are there any doubts in this code? So Gomatesh, why do we convert infix to postfix? So basically this is an application, that's it. Okay, application using stack. Okay, so this is one of the example where you can use the stack to convert infix to postfix. Like traversal example, you can take it up. Okay, one of the traversal example, that's it. Are there any doubts still? Yeah, Gomatesh, what is the biggest logical risk in this? I did not get the question, Gomatesh. Logical risk in the sense? Like you're asking about time complexity or
It's 8 o'clock.
Okay, time complexity, if you can see how many times you are running this loop for, until the length, right? Until the length you are running the loop. And here also you are checking the loop again, whether it is operator, you're checking the precedence for everything, right? So in the worst case, and outer also you're running the loop for popping it up until end, right? So for this outer case and inner case, I can consider the time complexity as big of n. Okay, big of n. And the outer case also, this one also in the worst case where you need to pop all everything when the precedence is again lesser only. So means like this if it is there. Like this it is there, star, dollar. If it is there like this, everything you will be inserting, nothing you will be popping it up, right? So in that case, everything you need to pop it up until n, right? So for that reason also, it will be big O of n plus big O of n. This will be the time complexity. Okay. Whereas space complexity as well, if you consider space complexity, you will insert everything onto the stack. Like if you miss the operands also, but you are inserting. Again, you are inserting, suppose only the operators were there. In the worst case, it will be go of an stack will be open, and you are taking one string builder for attaching your answer. Okay, one string builder also you're taking. So in this case, the space complexity will also be big O of n plus big O of n. Okay, both are same. Okay, so Shahrukh, did you join now or why are you saying good evening now when we are discussing in between? Why is that? Did you join now at 8 o'clock? Okay, so the remaining things like you can convert. Where is my pen? Okay, the remaining I have explained here infix to postfix. Okay, infix to postfix. So remaining two. What are remaining? Infix to prefix, infix to prefix, prefix to postfix. Like prefix to postfix. Can you do it from your end? Yes, these two things I'll be giving as an assignment to you. Okay, please write the code for this. Okay, write code for this by following the same pattern. The pattern will be same. Okay, the pattern will be same, but there will be some reverse conditions you should check. So from infix to postfix, how you're converting some reversible conditions you should check, and then you should do these things. Okay, you know what is prefix expression, what is postfix expression, and I've explained this blueprint as well. So you can follow this thing and infix and postfix and prefix. Some logic change will be there. Please try to implement it. Okay, are we clear until this point? Yes, everyone. Okay. So yesterday I have given one problem, right? Stock span problem, right? Where is it? Online stock span problem. Did anyone do this? Did anyone do this? So I'm giving an assignment, but no one is doing or no one is responding even like when assignment comes. I can't do anything. It depends upon you, your practice. Okay, this problem tells, let me explain again. Let me give the solution from my side only. Okay. So basically, the problem, the input will be given like this. Input will be given like this. So when it is stock spanner, when you're giving the test as stock spanner, it means you need to create a stack. Okay, you need to create a stack, empty stack. Okay, you need to create an empty stack. And then when it is next, you will be adding, you can create an array. Okay, not in empty stack. Just you create an array when it is stock spanner. And then when you are adding 100, when he is adding you to 100, just add it into your stack. Or just add it into your array. And then 80, and then 60, and then 70, and then 60, and then 75, and then 85. Okay. Now when he is asking, you need to add it up. And when he is asking the next, you need to find out the span of stack. You need to find out the span of stock. Okay. You need to find out the span of stock. Means span in the sense, suppose you are buying on the second day. You are buying on the second day. You are checking in the app. Whether yesterday also it is lesser or not. Yesterday, suppose you are buying at 12 price today. Suppose yesterday is 10. Then now the stock span will be 2. Stock span will be 2. Okay, because yesterday also this is a lesser. Today also the today is today it went decrease, it went increase. Okay, it went increase. But the thing is before day it is lesser. So you need to check how many days it is lesser than or equal. Suppose the first day you bought it on second day. On the first day it is 10 only, and the second day also it is 10 only. The stock span answer will be 2. In this case the stock span answer will be 3. Okay, so like this, suppose if you see 100, so before this nothing is there, so what you need to do next means you should give the answer as 1. Okay, and then you see 18, you see 80, so 80 before the 8 is greater, so the stock span will be again 1 itself. And then 60, before day you need to compare 80 is lesser than 60, yes or no? 80 is lesser than 60, yes or no? Students, are you there? 80 is not lesser than 60, right? So in this case again the stock span will be 1 itself. Then 70, again you need to compare. 60 is lesser than 70, yes, it is lesser. Okay, it is lesser, so plus 1. Okay, plus 1. And then 80 also will compare. 80 is lesser than 70, no, it is not lesser. So what you need to do, you need to add 1 plus 1, which is 2 here. So before 1 is 1, you will add 1, 2. Okay, 2 now. And then 75, 75, 75. 60 is lesser than 75, yes, plus 1. Then 70 is lesser than 75, yes, plus 1. And then 6, and then 60. 60 is again less than 75 plus 1. And then 80, it is not less than, so what you need to do, this 75 also you need to add. So 1 plus 1 plus 1 plus 1, which is nothing but 4. Okay, and then 85, 85 plus 1, and then 75 plus 1, and then 60 plus 1, and then 70 plus 1, 60 plus 1, 80 plus 1, 100 is not greater. So 1, 2, 3, 4, 5, and then 6. So what will be the answer in this case? It is 6. So triple 1, 2, okay, triple 1, 2, 1, 4, 6. I missed some operator here. So, okay. So triple 1, 2, 1, 4, 6, and then here it is null, because you are calling this operator, you are calling to create an array. So you need to give null there. Okay. So like this, you need to give the array. You need to give the array. Are we clear? Are we clear? Yes. So let me write it down everything. So how can I do this problem? 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 So if you can see here, I'm adding, I will remove all these things, clear all drawings. What I will do, I will, yeah, okay, 60, 70, 60, 75, and then 85, right? And then 85, okay. Okay, so basically what you need to do, suppose you are at here, brute force approach. Suppose you are starting the loop from here. Then what you are doing, suppose the count is 1. Initially the count will be 1 anyways, because here it will be 1 anyways, right? So what you'll be doing, if you are you need to traverse until the end of the loop, right? The brute force approach, if I'm explaining the simple approach, you need to traverse from 1 to 0, means you will be starting a loop from 1 to n minus 1, right? 1 to n minus 1, and then you'll be running another loop. You'll be running another loop, that is j is equal to I minus 1 to 0. Okay, until 1 to 0 you'll be running a loop, and you will check if if array of I if array of I if array of I lesser than, if array of I greater than, you will keep on checking previous elements, right? So if it is greater than array of j, if it is greater than array of j, then what you need to do, you need to just increment the counter. You need to just increment the counter. Okay, you need to just increment the counter, and then you will be adding that counter. You will be adding that counter. Suppose array list, if I'm taking array list dot add of count. Like this, you will keep on running the loop. Like this, will keep on running the loop. Suppose 60. So here it is not greater. Like you can also write one condition, if it is immediately this is greater, anyway, if it is this is greater, then you need not to check this, because immediate one, if it is greater, then stock span will not continue. It should be continuous, right? So in this case, it will be anyways, you will not check this 100. So see, your 60, 80 is anyways greater than 60, 80 is anyways greater than greater than 60, 60 is lesser than 80, so this condition will fail, right? It will not go inside. Then what you can do, you need not to check this one also. Directly you can break the inner loop. You can directly break the inner loop, and the array dot add will be, count will be 1. So like this you can perform the brute force approach. You're checking each and every thing, the previous elements you are comparing. But what is the time complexity of this? What is the time complexity of this? Time complexity, big of, you are running inner loop, forward loop, and backward loop. So until n, this one is in the worst case until n, and here also until n minus 1. We go of n into n minus 1. So what is the time complexity? It will be n square, right? N square. Can you decrease this? Can you decrease this to big O of n? Is it possible? Big O of n will be the question. Can you decrease this to big O of n? Is that possible? Space complexity will be anyways big O of 1 itself, because you are not using anything. Okay, you are just using for answer, you're just using array list, so it will be big O of constant space itself. Can you decrease this? Can you decrease this to big O of n from n squared to n? Is it possible? Yes, no. Okay, we can decrease this. So what I will do, so I will remove these drawings or I will use an eraser only. Okay, this is a simple approach. We can do this to big of n also. Using stack I will use. Okay, I will use a stack and I will decrease the time complexity from n squared to n. How I will do this? Let's see. So what I need here, what I need here, what I need here, I need to find out like basically like if I can find out suppose 60. Okay, 60 is there. Here I am traversing. Okay, in this the previous array anyways the count of 60 will be 1. Count of 60 will be 1. If I find out suppose here it is 60, I will find out 70. Suppose this one I am doing. Okay, now count of this will be anyways 1. Count of this will be anyways 1, right? So 0, 1, 2, 3, 4, 5, 6. Okay, now if you can see, so now this is lesser, this is also lesser, this is also lesser, and this is greater. This is greater. Means what you should do, if this is greater, you should stop the loop here. You should stop the loop here. You should not continue. Means these three elements will be the count value, right? These three elements will be the count value. So what is the count value? It is 4, right? 1, 2, 3, 4. So this index is what? 1, right? This index is what? 5. This index is what? 5. This index is what? It is 1. This is 5, right? It is 1, it is 5. So if I can subtract this index, if I can subtract this index, can I get this answer? Can I get this answer? Yes or no? Yes or no? For this also, I need to find out which is greater. Which element in the previous index is greater? Which element in the previous index is greater? Right? So this is only greater. This is only greater. So in this case, the count will be 1 itself. The count will be 1 itself. Okay, suppose this one. In the previous, I should check. In the previous, I should check which one is greater. So if you can see, 75 is not greater, 60 is not greater, 70 is not greater, 60 60 is not greater, 80 is not also greater, 100 is greater, 100 is greater. So it is 0 index, right? It is 0 index, this is 6 index. So many elements are there in between? 1, 2, 3, 4, 5. 5 elements were there in between. 5 elements were there in between, right? So what I will do, 6 minus of 0, 6 minus of 0, which is nothing but 6 itself. But the thing is 6 itself, 1, 2, 3, 4, 5. 5 and 6. 5 and 6. So that will be the answer. You got the logic? You got the logic? Yes. Yeah, we can identify greater or lesser. On the previous, on which element you are pointing, that you will compare with that element, right? So here I am comparing with 85, right? Here I am comparing with 85. It array of 5. I am comparing with 85. Each and every element I will compare with the 85. And then I will find out which one is greater than 85. There I will stop it up. There I will stop it up. Just increment the, just I will find out the index. Here it is 6. And what is the greater element? That index. I will minus it up and I will put it inside the list. Are we clear? Are we clear? Okay. So what I will be doing basically, we'll use an eraser. So what I will do for this, basically, I will use a stack. Okay, I will use a stack. So when it is stock spanner, what I will do, I will initialize the stack. I will initialize the stack. Okay, and then I will also take count as -1, count as -1, index also as -1, index also as -1, and then 100. Okay, and then 100, and then I will take one answer as well, one answer also. Okay, for storing this value. Okay, one answer also is 8:30 done. No, right, it's only 8:22. See your time, see your watch. Answer as so I'm taking one answer. Okay, I'm also taking the result one. Okay, and now what I will do, what if suppose the next is 100, right? Next is 100. They were passing next as 100. Okay, so in this case, what I will do, there is no nothing element on the top. Okay, there is no nothing element on the top. So in this case, what I will do, I will just push this element onto the top, push this element onto the top along with the index, along with the index. Index is what? Index is 0, right? 0, right? And then I will calculate the answer as well. So basically for this 100, what is the answer? So answer is like answer will be like, you give it the formula like, so initially the index, right? So index of current element, index of next element minus, like you can take it as index of current element, index of I minus what is the previous index, previous index. Okay, previous index. So previous index is what? Previous index is -1. So 0 of -1, which is nothing but 1. Okay, which is nothing but 1. Okay, so 100 is 0, 0 minus of -1, which is nothing but 1. And then 80 is whatever you are adding. Next is 80. 80 is greater than 100 or lesser than 100? Lesser than 100. When it is lesser than 100, directly you can pop it up. Okay, you directly pop it up. When your current element is lesser than 100, you can directly pop it up from the stack, the previous element. But before popping, just calculate the index. So what is the previous index? Previous index is 0 and current index is, you are pointing at second one, right? 0, 1 and 2. You're pointing at 1, right? So in this case, what will happen? For this 1, okay, for this it will be, the index of 80 will be 1 minus 0, which is again 1. The answer will be 1 for this also. Okay, then you can add it into the list for this also. And then 60, next of 60, next of 60. So 60, now you will push it up into the stack. This 80 also will push it up into the stack with this index 1. Okay, now you are adding 60. Okay, you are adding 60. 60 is lesser than 80. 60 is lesser than 80. So in this case, what you need to do, you need to find out the index first. Okay, what is the previous index? It is 1, right? It is previous index is 1. 2 minus 1. 2 minus 1 is again 1 itself. Okay, 2 minus 1. Index of 60 is 1. So 2 minus 1 is again 1 itself. So what you can do, you can just add the, you need to pop this 80 and you will add the 60 onto the stack. Okay, onto the top of the stack, you will add the 60 and its index. Index is 2. Okay, then you are having 70. Then you are having 70. So 70 is greater than 60. 70 is greater than 60. So what you will do now, when 70 is greater than 60, So again, you will find out the index. Okay. So what you can do, just you can add it into the, when 70 is greater than 60, just you will add it up into the, okay, add it up 0, like 1, 2, 3, 4. Okay. 0, 1, 2, 3. You will add the index. And what is the formula you need to calculate? 3 minus 2. Okay, 3 minus 2 plus 1. 3 minus 2 plus 1. So what you need to do? You need to add 2 here. 3 minus 2 plus 1. Whatever is the previous value, for that you will add it up. Okay, you will add it up. So now the answer will be 2. Answer will be 2. And then next one is 60 again. Next one is 60 again. Now 60 is lesser than 70. So what you need to do? You can remove this. You can remove this. So what is the thing? 1, 2, 1, 2, 3, 4. Okay, 4 minus 3, which is nothing but 0, 1, 2, 3, right? 3. 3 and this is 4, right? 4 minus 3, which is nothing but 1. Okay, which is nothing but 1. You will pop it up. Okay, then again 60. 60 is lesser than or equal. Then in this case, what you will do? You will add it up into the, 4 and you will add the previous result. We are at the 60, right? 60. Right? You can directly add up the previous result. You can directly add up the 1 year. Okay. You can directly add up the 1 year. Okay. Then again, what is there? 75. 75 is greater than 75 is greater than 75 is greater than 60. When it is greater than 60, what you need to do? When it is greater than 60, what you need to do? You need to calculate this, right? So what is the current index? 5. 5 minus 4, which is nothing but 1, right? 5 minus 4, which is nothing but 1. You will pop it up. And then again, you will compare with the next one as well. 2, right? Again, you will compare with the next one. Next one is already there, that you can leave it up. Okay. So you'll just add 1 there. Okay. Then 85. And again, you will compare 85. 85, again, you will compare with 85. 85 is lesser than 85 is lesser than 60 again. 85 is lesser than 60 again. So what you need to do? What you need to do? You can remove this. You can remove this from the stack. Okay, you can remove this from the stack. And then what you will be doing? 85, which is nothing but 85. What is the index of this? 2, right? So 1, 0, 1, 2, 3, 4, 5, 6. 6 minus 2. Okay, 6 minus 2, which is nothing but 4. 4 plus you will be adding the previous index as well. You'll be adding the previous index as well. What is the previous index? Here it should be 2, right? It should be 2. We need to add the previous index also. So okay, 4 plus 2, which is nothing but 6. You'll be adding this. Okay, so like this, you will solve this problem using stack. Okay, so in this case, the time complexity will be only big O of n itself, and the space complexity, since you are adding all the elements, it will be big O of n, since you are using a stack. Okay, since you are using a stack, it will be big O of n. Are we clear? Okay, so when I explain the code, you will understand. When I explain the code again, you will understand. Okay, I will write down the code on the editor and then I will do that. Okay. When I explain the code, you will understand. Okay, let me move this editor to the top. Give me a moment, I will drink some more drink. Okay. Okay, so when it is stock spanner, what you need to do, you need to initialize your stock. You need to initialize your stack, right? So I'll be initializing the stack, which is of array type. Okay, since you need to store the element as well as the index. So for that reason, it will be of the array type. So new stack. Okay, new stack you'll be initializing, and then now you'll be taking an index as well, right? You'll be taking an index as well. This index you will be initializing to -1. Okay, index will be initialized to -1. You need to declare the index here. Okay, this you can initialize to -1. Okay, this also you can initialize on the top. Okay, and then what you need to do when it is next, when it is giving the next price, you should write your logic. So what is the logic we are done? Yes, int index is equal to -1 initially. Okay, int index is -1. Did I do any mistake there? No, right? So what you'll be doing, you should check on, right? You should check while the stack is not empty. While the stack is not empty, or while the stack is not empty. Okay, and st dot peak. Okay, st dot peak when it is when it is lesser than or equal to price. Okay, when it is lesser than or equal to price. Arch chain, like if you have marked your attendance and if you're not interested, you can leave. Okay, so don't disturb the class. The class is done for you, you can leave. Okay, you can directly pop it up when it is lesser than or equal to your price. You can directly pop it up. Okay, you can directly pop it up. Okay, and then what you need to do, you need to calculate the index as well. You need to calculate the index as well, like I'm taking it as span, like basically your answer. Okay, so like what you need to do, you need to index minus index minus index minus, you need to calculate, you will be checking whether it is like whether it is empty or not also. Okay, whether it is empty also, you will be checking if it is empty. If it is empty, what is doing? The index will be -1 itself. Otherwise, the index will be st dot peak. Okay, st dot peak. That is the index of that element. Okay, index of st dot what is there on the peak, that particular index you need to calculate. Okay, index of peak of 0, since you are storing the index, okay, of 0, what is the index of that, you can calculate that. Okay, so then you will be pushing the other one onto the stack. The other one, what you will be pushing, you'll be pushing the current one, that is price, onto the stack. Price comma, you should put the index as well. Like, so what you need to do, like basically new int of price comma, okay, new int of price comma index. You'll be pushing that particular index. Okay, you'll be pushing that particular index of that element. Okay, index of that element. Okay, then you can directly return the span st dot push of price comma index. Okay, correct. And then what you need to do, if it is like if it is lesser than or equal to, you will do this. If it is greater than, what you will be doing, if it is greater than, directly you can push it up. Okay, if it is greater than, directly you can push it up. st dot push off, st dot push off, what you will doing, like new int of your price comma index, directly you can push it up. Okay, directly you can push it up if it is greater than, and then you will return the span. Okay, so this will be the thing you will be doing inside the stack. So this one, so we'll just push it up afterwards, and then what you will do is the span. Okay, st dot push off. When it is not there empty, then you will do this. Then this is correct. Then st dot push off price comma, you need to like you can take price comma of 1, right? This is your index, you're pushing it up. And then what you need to do, you can take like index is initially -1, so you can do a plus plus. Okay, index is initially -1, you can directly do a plus plus there. So this one I'm writing 2 times. Okay. Yeah. So new int of, you will be returning the span as output. Okay. So this will be the answer. While lesser than or equal to, you will be checking the price as well, but st dot peak of I, it is less than or equal to price. Then what you are doing, you are popping it up. Then when you are calculating the span, when it is empty, the stack is empty, then what you are doing, you're just putting it as -1. Okay, for index you will be putting it as index minus -1. Okay, when it is not empty, you are calculating it with that particular thing, top of the element what was there, then you are returning it. Let me check if this is running. Okay, st dot peak only, right? What it is telling, lesser than or equal to price only, right? Lesser than or equal to xt dot peak lesser than or equal to price itself, right? I have written. Okay, here in the peak we have the array, right? So 1, okay, 1 lesser than or equal to array because this is a array type. Cannot invoke java.util.stack dot empty. Okay, it should be is empty. Is empty. Oh, right is doing like this. New stack cannot invoke java.util.stack.is empty because st this dot st is null. Oh, that's went wrong. So why it is moving wrong? Expected output is 357. You are getting it. 357. Why is it like that? Index plus plus. Index is index. Okay. Then index is -1. Then you are doing the index plus plus inside. Index plus plus inside, and then while st dot is empty and st dot peak of 1 lesser than or equal to price, then you are just popping it up. Then you are just popping it up and you are calculating the index minus st dot is empty when it is when the condition is matching. You are taking the -1 or else you are peaking it up to empty. Okay, picking it up to empty lesser than or equal to price itself. Top of correct. Then push off price comma index. Push off mean price comma index. Then you are returning the span. Okay, so oh yeah, okay. So here it is price comma index, so it will be 0 here. So you're entering price, right? You need to compare with the price, not with the index. Right, correct. Still it's not going up. So new int of price comma index, and if it is you are comparing with the price, okay, this one should be 1 itself, this one should be 1 itself, here it should be 0 because you're comparing the price here. Right, it's working fine. And when I click on submit, okay, all the test cases passed. Yes, 99 test cases has passed. Okay, so this will be the solution. Okay, so if you want me to explain again, let me explain it once again. So like I will give the dry run to you only, this problem, what you can do. I will give this code to you. You dry run it yourself. Okay. You dry run it yourself and let me know if there are any issues at your end. Okay. Anurag, you try it at your end and you will understand. Definitely you will understand. Okay. If you're not still getting, let me know. I will explain tomorrow again. Okay. So because it's already time up, I need to explain again trees as well. So I'm going forward. So next one, I thought of explaining that the other problem. Explaining the other problem, that is null pointer exception you will get because your stack is not initialized, I guess. Your stack should be initialized properly. Then you should call isEmpty method. Okay. So I thought of explaining that building problem also, but time is not sufficient. Tomorrow I will take that. Okay. So now I will going with the trees. I'm going with the trees. So can you tell me what is a tree? So nonlinear data structure, right? Nonlinear data structure. Nonlinear data structure. So basically you will have like this, right? So suppose like this. This is called as your tree, right? This is called as your tree. So 10, 11, 12, like one node is connected to many other nodes, right? So in tree, like if I can explain the terminology, this is nothing but your root node. This is nothing but your child node of it, right? Like this is also a child node of this. This is also a child node of this, right? Children node or child node of this. And it is also considered as a leaf node. Right? This is also considered as a leaf node. And for this 13, this is a parent node, right? This is a parent node. And for this 12, this is again the parent node. This is again the parent node, right? So like this, like if you consider ancestor node in the sense, ancestor node in the sense, for this is the this is the parent, this is the grandparent. So these are all considered as your ancestor nodes also. Okay, these are all considered as ancestor nodes also, right? So if you can consider the height of the tree, so height of the tree is considered through level wise. Okay, so this is your level 1, this is your level 2, this is your level 3. The height is 3. Height is 3, right? Height is 3. So like this, you will do the terminology. And there are like different types of trees over there. Like you have the complete binary tree. You have the complete binary tree. And complete binary tree in the sense, like each and every node will have at least 0 or 2 nodes. Each and every node will have at least 0 or 2 children, 2 child nodes. Okay, so this is considered as complete binary tree. Is this a complete binary tree or not? Is this a complete binary tree or not? Yes or no? Okay, sorry, this is full binary tree. Okay, is this considered as full binary tree or not? It is not considered as a full binary tree because here you see 11. For 11, you have only one node. For 11, you have only one node, right? You have only one node. For 12, you have the two nodes. But for 10 also, you have the two nodes. But 11, you have only one node. It should have either 0 nodes or 2 nodes. At least it should have 2 nodes or 0 nodes for each node, right? So it is not considered as a full binary tree. Whereas complete binary tree, complete in the sense, complete in the sense, all nodes are like complete in the sense all can be anything. Okay, all levels are completely filled except the last level. Okay, all levels can be complete are completely filled except the last level. See, this is the last level, right? This last level you can leave it up. Okay, this last level you can leave it up, but these levels should be completely filled. This is completely filled. This has two nodes, but this has only one node, but it is considered as a complete binary tree. Okay, because last level you can ignore, but before levels you should consider. So that is called as a complete binary tree. And then we have the perfect binary tree. Perfect binary tree. Perfect binary tree. So in the complete binary tree, all nodes should be occupied, all levels should be with two nodes, but the last node, like only last node, like all the nodes should be in the left. Okay, left if it is there, that is okay. So see, for this left is there, for this also left is there. It may not be fulfilled, like two nodes it can't be, but it can be if the left the nodes were there, then it is called as complete binary tree. Okay, then perfect binary tree. Perfect binary tree in the sense all leaf nodes should be at the same level. Okay, it should not be like this. It should not be like this. Then this is not called as a perfect binary tree. This is called as a perfect binary tree only because all nodes will be at the same level. Okay, all nodes, all leaf nodes should be at the same level. Okay, all leaf nodes, if they are the same level, that is called as a perfect binary tree. Okay, and then you have the balanced binary tree. You have the balanced binary tree. Balanced in the sense, balanced in the sense, balanced in the sense, balanced in the sense. Suppose there are like you wanted to draw the 6 nodes. This should be of log 2n. So 6 log 2n. Okay, that is 3, right? So it should be equally it should be there. The 6 nodes should be equally in the balance. It should be balanced basically. Okay, means it should be occupied in the 3 levels. It should be occupied at least in the 3 levels. Okay, 1, 2, 3, 4, 5, and then 6. So this is a balanced binary tree. It should be occupied in the it should be occupied in the balanced level, balanced in a balanced format. It should be okay. Same node, like you can consider it as same nodes on the both sides, or like it should be at least 3 levels. Suppose if you're considering 8 nodes should be there, then log 2, it should be of this format, log 2 of 8, which is nothing but 4, right? So 4, it should be like it is 3, right? 3. It should be also of the like at least three levels should be there for all the 8 nodes. Should exactly have the 3 levels. Okay, so that is of the balanced binary tree, same nodes on both sides. It's correct. And then degenerate tree in the sense you can consider it as a skewed tree. So basically only one level will be there, only one level will be there. So that is called as a degenerate tree. Okay, if you're drawing the tree in only one level, one parent will have only one node. That is called as a one parent will have only one single child. That is called as a degenerate. Okay, so these are all the types of trees. These are all the types of trees. Okay, in binary trees, these are all the types. So you have the full binary tree, you have the complete binary tree, you have the perfect binary tree, and then degenerate binary tree as well as balanced binary tree. Okay, so these are all the types of the types of the binary trees. Okay, and then coming to the tree traversals. Okay, tree traversals. Coming to the tree traversals. So basically we have the two types of tree traversals, that is BFS, DFS. Okay, in again BFS, okay, in DFS in the sense depth for such, depth in the sense like this is nothing but a depth, right, from 0 to root, from level 3 to root, that is nothing but a depth of the tree. Whereas breadth in the sense level wise, if you are traversing, that is called as breadth. Okay, so in this is nothing but BFS is nothing but breadth for search, which is level wise. Okay, level wise. Whereas depth first search in the sense you have 3 traversals here. Okay, in order traversal, reorder traversal, post order traversal. Okay, in order traversal, reorder traversal, post order traversal. In the case of a in order traversal, you will first traverse the left node, then root node, then right node, then right node. Whereas in the case of pre-order traversal, you will first traverse the root node, then left, and then right. Then in the case of post order traversal, you will first traverse the left node, then right node, then you will traverse the root node. Okay, so this is the post order traversal. Okay, so these are all the traversals we have in DFS. Okay, we will see how this traversals works tomorrow along with the code. Okay, so basically you need to traverse left, root, and right, and we'll see this code also tomorrow. Okay, for today, what I'll be giving as assignment, yesterday assignment only I will give. Okay, so what is the assignment I have given before? Like the traversals, right? Prefix to postfix. Those you need to write the code, prefix to postfix, pre to post, post to pre. Pre to post, and then post to pre. These two things you need to write the code. Okay, and then work on that problem only, the building problem. Okay, the building problem what I have given yesterday. Okay, trapping rainwater problem. Okay, what I have given yesterday, trapping rainwater problem, work on the same problem tomorrow also. Okay, so these three things will be the assignment for tomorrow. So tomorrow we will continue these trees. Okay, we'll see two more problems on trees, and then we'll go into the BST as well, balanced such trees, and then we will also continue the graphs. We'll start the graphs and graph traversals. Okay, so this will continue tomorrow. Okay, are we clear until this point? Yes. Are we clear until this point? Can I get a heads up in the chat box, everyone? So please complete the assignment. Don't ignore it. Okay, important. Okay, please try to complete your assignment and come back tomorrow. Okay, so I'll be asking questions from this assignment also. Make sure you're answering. Okay, so on that note, thank you so much, guys, and have a very good night. Thank you, guys. Over to you, Sushmita.
Yeah, thank you, sir. Thank you so much. Yeah, so students, attendance link is shared it on a chat once again. Please mark your attendance. Yeah, we can wind up for the day. Thank you all. Thank you for joining. Good night.